In today's data-driven world, businesses are constantly seeking ways to extract valuable insights from the vast amounts of information they collect. Business intelligence tools, such as Microsoft Power BI, have emerged as powerful solutions for transforming raw data into actionable knowledge. However, the true potential of BI lies not just in the tools themselves, but in the often overlooked art of data modeling. Effective data modeling is the backbone of successful BI initiatives. It lays the groundwork for accurate analysis, insightful reports, and informed decision-making. Without a well-structured data model, even the most sophisticated BI tools can produce misleading or incomplete results. Data modeling, in essence, is the process of organizing and structuring data to represent real-world entities and their relationships. It involves defining how different pieces of information are connected and how they interact with one another within a database or a data model. Think of it like building a house. You wouldn't just start piling bricks on top of each other without a plan. Similarly, in data modeling, you create a blueprint that defines the structure and relationships of your data. This blueprint ensures that your data is organized logically and can be easily accessed and analyzed. Power BI provides a robust and intuitive environment for data modeling. It allows users to import data from various sources, establish relationships between datasets, and create complex calculations to derive meaningful insights. The Power BI data model is based on the concept of tables, relationships, and DAX, data analysis expressions. Tables are like spreadsheets containing rows of data and columns representing attributes. Relationships define how data in different tables is linked based on common fields. DAX is a powerful formula language used to create calculated columns and measures, extending the analytical capabilities of your data model. The first step in Power BI data modeling is importing your data from various sources. Power BI supports a wide range of data connectors, including Excel spreadsheets, text files, databases, and cloud services. When importing data, it's crucial to ensure data quality and consistency. Clean and well-structured data is essential for accurate analysis and reliable results. Power BI offers several data transformation and cleaning features within the Power Query Editor to help you prepare your data before loading it into the data model. Once you have imported your data, the next step is to establish relationships between different tables. Relationships define how data in one table is related to data in another table based on common fields or columns. For example, you might have one table containing customer information and another table containing order information. By creating a relationship between these tables based on the customer ID field, you can analyze customer orders, purchase history, and other related metrics. Step 3. Calculated columns versus measures. Unveiling the power of DAX. Calculated columns and measures are essential components of Power BI data models. They allow you to create new data points and perform complex calculations based on your existing data. Calculated columns are added to a table and apply calculations to each row within that table. For instance, you could create a calculated column in the orders table to calculate the total order value by multiplying the quantity and unit price columns. Measures, on the other hand, are calculated at the time of aggregation, such as when you create a visual or a pivot table. They are used to perform calculations across multiple rows or tables. For example, you could create a measure to calculate the total sales for a specific product category across all customers. Common data modeling scenarios in Power BI. Power BI is used across various industries and business functions, each with its unique data modeling requirements. Some common data modeling scenarios include sales analysis, modeling sales data to track revenue, customer behavior, and product performance. Marketing campaign tracking, analyzing marketing campaign effectiveness, customer segmentation, and return on investment. Financial reporting, creating financial statements, dashboards, and performance reports. Inventory management, tracking stock levels, order fulfillment, and supply chain efficiency. Avoiding common data modeling pitfalls. While Power BI makes data modeling accessible, there are common pitfalls that beginners should avoid. Ignoring data quality. Poor data quality can lead to inaccurate analysis and misleading results. Always cleanse and validate your data before loading it into the data model. Creating unnecessary relationships. Too many relationships can complexify the data model and impact performance. Establish only necessary relationships based on logical connections between tables. Overusing calculated columns. While calculated columns are useful, overusing them can slow down report performance. Utilize measures for aggregations and calculations that don't need to be performed for each row. Conclusion: embrace the power of data modeling. Mastering data modeling is essential for unlocking the full potential of Power BI and other BI tools. By understanding the fundamental concepts of data modeling, you can transform raw data into meaningful insights, empowering your organization to make informed decisions and drive business growth. Remember, data modeling is an iterative process. Start with a simple model, experiment, and refine it as your understanding of the data and business requirements evolves. With practice and exploration, you can become proficient in data modeling and harness its power to gain a competitive edge in today's data-driven world.